So let's look at example number 3 that deals with Hooke's law. So suppose we have a block of mass m placed on an inclined plane attached to two springs in parallel to one another, and each spring has a spring constant of K1 and K2, and these springs are attached to a wall. Suppose the angle of the incline is 30 degrees. So this angle is 30 degrees. Find the total spring constant of our system. So we want to find the single spring that has a spring constant that will replace these two springs, or these two spring constants. So to begin our problem, we must find the force that is pulling down on our springs. That's pulling down on our object, our mass m. To find this force, we basically take our force of gravity and multiply it by the sine of the angle that this inclined plane makes with our ground. So remember, the force that's pulling down along this inclined plane, along this x-axis, if we're looking at this to be our x-axis and this to be our y-axis, is simply the magnitude of the force of gravity multiplied by the sine of the angle. So let's look at all the forces that's pulling down on my object and all the forces that are pulling up on my object. So the forces that are pulling down is simply one force. It's f of g times sine theta. So it's this force here. But how many forces are pulling up? Well, two forces are pulling up. One force is due to this spring, and a second force is due to this spring. Remember, this spring, spring 1, has a constant of K1. And this spring, spring number 2, has a constant of K2. So, remember, we have to use Hooke's law, which basically tells us that the force is equal to negative of the spring constant times displacement or distance that our spring stretches or compresses. So, this force times sine theta is equal to the two forces, this force plus this force. So we get negative in parentheses K1 times displacement x plus K2 times displacement x. So these two springs displace the same amount, but they have different spring constants. So that means I can take out a constant, this guy, which appears on this side and on this side. So let's take that guy out, and I get negative change in x in parentheses K1 plus K2. And since our angle is 30, I plug in 30. And I get, since sine 30 is simply 1/2, I get my force of gravity divided by 2 is equal to negative change in x in parentheses K1 plus K2. Now this negative simply comes from the fact that these vectors are in opposite directions. They point in opposite directions. So where this force is pointing downward, the force of gravity is pointing downward, and this guy is pointing upward. And we choose this direction to be positive and this direction to be negative, and that's where the negative sign comes from. This distance is simply the change in our spring. So how far does our spring stretch out? And both springs experience the same displacement. Now that means that my total spring constant, or that K total, is equal to K1 plus K2. So it turns out that whenever we place 2 springs, 3 springs, 4 springs, and so on, whatever number of springs in parallel to one another, we simply add these guys up, add the spring constants up to get our total K. And this simply means that if I wish to replace these two springs with another spring, with a single spring, that single spring has to have a constant of K total.